Right, hello, and welcome to this little bonus video I'm doing because I wasn't quite happy with the video I put out on Wednesday because it's a bit basic, so I thought I'd do something extra for you. Basically, this video is going to be sort of getting sort of a grid of pathfinding nodes for the AStar algorithm, based just on the new tile maps that Unity have implemented in one of the most recent versions, which we're going to play around, which are quite nice actually. I like them. I need to do some tweaking with them to make them work the 2D isometric project I'm working on. But yeah, so if you are following along with the 2.5D RPG, then this is sort of like, I don't know, it's not technically episode, but whatever, you can add it if you want. But yeah, so as you can see from this, we've generated a grid of nodes based on this tile map. And we will, it's like identified bits of the map that aren't walkable, so these walls and stuff. And you can see that this NPC here can follow them. And yeah, and my pathfinding is throwing an error for some reason, but we're not here to do pathfinding, we're just here to generate the grid of nodes. So you'll need your own AStar implementation. But basically all we're doing is just creating the 2D grid of nodes, and it'll find out all the neighbours and whether it should be accessible or not, and all that stuff. So let's just get onto it. Okay, so first off, we're taking the grid base. So that is here. Basically, it's just the parent object of all the tile maps which you have here. This is used basically just for making sure that the nodes are in the correct position a little bit later on. Next up, we have a tile map for the floor. That'll be the floor of the world. So in this case, we've just got a load of brown tiles to represent dirt. That is sort of the bottom, so each tile in the... So this is kind of like the base of the world, so each of these tiles in the tile map will have a pathfinding node related to it. But based on the tile maps passed in as obstacle layers, the nodes might be walkable or not. Unwalkable or not, sorry. So that's how we work it. So we can have multiple obstacle layers, so you might have different layers for trees, walls, stuff like that. And all of these things would block the pathfinding of objects, so I just thought that'd be useful things to have multiple layers of. We've got a node prefab. You might want to just have it as not a game object for, I don't know, if you want to do multi-threading or something for your pathfinding, but just to sort of visualize it, I have made the nodes game objects. And I'll just mute that from Facebook. Okay, next up, because of how the tile maps work, basically, as far as I understand it, it's like all the textures are being rendered onto a single mesh, so there isn't like an array of game objects you can access, so we have to sort of use a bit of a workaround to get the data out of the tile map and as nodes. So basically, we're defining an area in the world space that we want to search through for nodes, or for the tile map. So basically, we're having a 500 by 500 square, which starts at -250, -250, and goes to 250, 250. Just so we can search that area for a tile map. You could have a small one if you're more precise about where your tile map is actually going to be. But I've just got a fairly large one just to make sure we don't miss anything. Next up, we have a list of unsorted nodes. This is just where they've put when the nodes are created, just so we can access all of them in a list. And then we have a 2D array, which is going to be the final bit that we put them in when they're all in the correct position relative to where they are in the world and their neighbours and stuff like that. Okay, so in Awake, we just initialize the list of game objects. So we don't do the nodes just yet because we don't actually know how big the size of the map will be. But that'll be something we work out with code. Then we just generate the nodes here. This is basically called from my world build script, so yeah. So basically just cuts called on start. First up, we have a public int grid bound x and grid bound y. This is basically just a way to keep track of how big the actual grid of tiles should be, so that'll be defining the size of this 2D array here while we are actually creating the nodes. Next up, we have values for grid x and grid y. Basically, because in this like 500 by 500 area we're searching, there won't be like a 500 worth of tiles. There'll just be tile map in that area, and we use this grid X and grid Y to sort of track what the index of that tile should be. Sorry, I'm messing this up. Basically, this is what tracks the index numbers for the tiles. Yeah, just stores the index, and that will change, be stored in each of the nodes that we're doing. Sorry. And we'll found tile on last pass. This basically just makes sure that we've found a tile when we're wanting to increase the grid X and grid Y values, so we're not including just empty space in the grid, which would be bad. Okay, so next up, we go through the world. Basically, we do a for loop to go through our X, through the X and Y. So that'll be 500 and 500, going from minus 250 to 250 for both. And then we use this method that is a tile map method called getTile, and it will return a tile base, which is basically just the tile that they use in these tile maps. And it takes a vector-free int, which, if you couldn't guess from the name, it's a vector-free, but it's integers instead of floats. Yeah, whatever. So basically, like I said before, the tile maps don't actually store the tiles as like a 2D array of tiles. It's more, we have to use the actual world coordinates where it'll check if there's a tile at that coordinate. And if there is a tile at that coordinate on that tile map that we've checked on, it will pass it in and store it on the tile base. Now, if tile base is null, so it's not found a tile at that particular location, then we do nothing. Otherwise, we have a bool for found obstacle to check whether there is a tile at to check whether there's an obstacle on that particular tile, and to find out if there's an obstacle, we go through each of the obstacle layers. So again, that might be rocks, walls, stuff like that, and we get the tile there. And if it's null, we use the same getTile method, but in this time we use the obstacle layer tile map. If it's null, so we haven't found a tile there, then we're fine. If we do, we've found an obstacle. So we've found obstacle to true, so we'll set that node to unwalkable later down the line. Next, brain fart. What is it? Yeah, this basically just adds an edge around the nodes. What it does is it'll add like basically, if you've got an unwalkable node, it'll add another like ring of unwalkable nodes around it. Just if you wanted to make an edge around it to stop people or pathfinding objects getting stuck on stuff. Yeah, if that's the kind of thing you want. Then we'll basically use this getNeighboringTiles method that I've created. So it takes the X and Y coordinates in the world, as well as the tile map that is being checked. And what that does is, that was getNeighboringTiles. getNeighboringTiles. Yeah, so basically it has a list of tile base, and what we do is for int x I equals x minus unwalkable node border. So this is like the size of the border. So I've got a default of 1. So it'd go from x minus 1 to x plus 1 and y minus 1 to y plus 1. And it'll get the surrounding tiles. And if they're not null, then it will add them to the return value, and it will return that list of tiles. And then it will check those tiles, and if the tile is not null, then it also set found obstacle to true. And then if we haven't found an obstacle, so if found obstacle is false, then we create a node here. We create the node, store it as a game object here, and then we create it. It's the position we create at is the x coordinate plus 0.5, so it's in the center of the tile, plus gridbase.transform.position.x and .y respectively. This is because I'll just show you it quickly. Actually, what it can be. Basically, I've got my tile map here, but technically the center of the tile map is actually over here. So this is basically just to make sure, if your tile map isn't on the proper center, isn't directly on the center or something like that, it basically just makes sure that the nodes are placed in the right place rather than starting at 0 itself. So if I moved my tile map to say there, that might not actually do it, but yeah, no, it has done it. It'll still create the nodes, and if I move it back again to the camera, again, it will still create the nodes in the correct place. So that just basically makes sure that the nodes line up with the tile map nicely. Yeah. Then we get the world tile component, which is basically, I'll get this here, world tile. This is basically just my AStar node class. It's got the G cost and H cost, grid X, grid Y, whether it's walkable, its neighbours, and its parent, and a method for the F cost. This is basically just your standard AStar node. If you want more information on the AStar, how to implement AStar algorithm, I believe Sebastian Lee, I'm not sure how to pronounce his name, but he has quite a good tutorial. He covers quite a bit, like multi-threading and that. So go check out his tutorial if you want a tutorial on implementing it. This is just for getting nodes from Tilemaps. So yeah. So we also set found tile on last pass to true to say that we can increment our grid X and grid Y values on this particular pass. And we also set our grid coordinates for the world tile script. And we add this node to the list of unsorted nodes, and we just name it whatever its coordinates are. If there was an obstacle found, we basically just go through the same process, except we set the sprite renderer on the node to be red, and we set the walkable to be false, because we don't want to walk on it. Next up, and then finally, after this, we increment the grid Y, because of how we've got the loops going. Basically, we're working... how to do this? I've got a sprite open, actually. File new. 100 by 100. Basically, the loop is going like this. So, well, that's too big. One. So this would be the first one, second one, third one, fourth one, fifth one, and sixth one. And this will be the end of the interior loop. So basically, we want to increment the x-axis while resetting the y to 0. So this is x is blue for that. So x 0. So the x is 1 and 2, and then we just keep going with the y. So that'd be y1, 0, y1, y2, y3, y4, y5, and that pretty much. So yeah, that is basically how the looping works and why we increment the y rather than the x first. So yeah. And then we make a check to see if the x or y values for the grid X and grid Y, which we're using to keep track of the position of the node, what it should be in the 2D array. We basically want to make sure that if they are bigger than the current grid bounds we have recorded, then we set the grid bounds to be equal to that value, because we need to know what the full size of the 2D array is going to be, so we can initialize it later on. And finally, once we've exited the interior loop, so that would be just the y, but before we finish the x loop, we want to check if we found tiles on that last pass. So if we were finding tiles and creating nodes on that pass, or not just finding nothing, then we want to increment the grid X value and reset the grid Y to 0, so it's on the bottom, and found tiles on last pass to false. So we can do that, and that's about it. That's about it for the creating of the nodes. Next up, we are on the this bit basically puts the nodes into the 2D array. Fairly simple. Basically, we just initialize the nodes array as a 2D array of grid bound x plus 1 and grid bound y plus 1. I was getting an error, or what is it? Null reference or something, or index out of bounds. That's the one. I'm not sure why, because it should have been the right size, but just to be safe, I added 1. It shouldn't matter if the array is one row too big, because it works fine, and it won't actually check those indexes because there aren't any nodes there. So that should be all right. And then I'll basically go through each of the nodes in the insorted nodes, get the world tile script, and place that node into the 2D array based on the grid coordinates we assigned when we were creating them. So here. And after that, we go through each of the tiles in the 2D array that we just filled. So we go for x equals 0 to grid bound, and for y equals 0 to grid bound. First off, we check if the node is null. So, like I said, if you had a kind of oddly shaped grid or tile map, so say this bit here, it wouldn't. What is it? There would technically be a space in the 2D array for this area, but it'd all be null because there aren't any tiles here to create nodes from. So that is why we go through. I just launched uTorrent. That is why we check for if the node is null. But if it's not null, so if there is a node created there, so there'll be a tile by extension, then we basically just get the world tile component and we assign its neighbors. So that would be just a list of nodes that it's adjacent to or that are accessible from it. Sorry. Using the we saw it there, which is used in the AStar algorithm. We use get neighbors method. We pass in the x and y coordinates of the tiles and the width and height of the actual grid, which I will explain why it is needed in a second. So basically what we're doing is we're passing in the x and y of the tile or node and the width and height of the array. We need the width and height to basically make sure that if we are on the edge of the grid, then we don't try and access like one to the right or above it and get an index out of range exception. So basically what we do here is we check if the x is more than 0 and less than width minus 1, and if the y is more than 0 and y is less than height minus 1, then that basically says, okay, we can check for a tile on all 4 sides of this node. Whereas if x was 0 or x was width minus 1, then we'd have the problem of we'd only been able to check on 3 sides or 2 sides. So we need to account for that. And since we could potentially have empty spaces within the array if you do have an odd-shaped tile map, then we need to check if each of these locations is null. So if we check x plus 1, so that would be above the node that you passed in. If it's not null, then there's the tile there, and we try and get the WT1 world tile, the node of it, and we add it to the list of return values. So my neighbors is what we return, and we do this for every possible incrementation, every possible like sort of set of chances. I don't know what the word would be for. Every possible iteration, maybe, of like where it could be in the grid, and like what kind of neighbors it'd have that be accessible. And it does that. And this script, I'll basically just find somewhere to copy and paste it so you can access it. And at the bottom, once it's got all possible neighbors, it will return them. And there you go. Once it's done it all for that, you have your grid of nodes. It's pretty simple. So yeah, and then for my implementation, we just pass it into this pathfinding. Do we do it? No, we pass it into the world builder, sorry. Which basically has a 2D array of its own of world tiles. And I think I covered this in a tutorial, but I don't know if I glossed over it because I've done AStar a couple of times. But yeah, someone's probably done it better than me, so yeah. And that is how we create nodes from a Tilemaps. So yeah, I'll shove this on Pastebin and have a link in the description. If you are basically, yeah. So that was the bonus episode. I hope you enjoyed it. Small plea, basically I've got a game out on Steam now. It's called Loud or Quiet. It's like a top-down shooter in the sort of art style of Hotline Miami. And it's got a bit of Payday and Max Payne and stuff. A bit like stealthy and actiony and stuff like that. So if you could give it a check out, I've just released a patch, improving performance a little bit, and changing some art assets that I wasn't happy with. So yeah, if you like that sort of thing or just want to support the channel, go check that out in the description. Cheers for watching. Like, comment, subscribe. If you got any suggestions or feedback, leave it in the comments. Yeah, goodbye.